2013 AB problem 5. Let f be that, g be this. Let R be the region bounded by the graphs of f and g, so no tricks. It is important to get an idea of which is which, though, and they leave that to you to reason about. So probably you should just know enough about the cosine wave to know that this is g, and the bottom one then has to be f. So find the area of R, and this is a simple top minus bottom kind of an issue. Now the job is to find antiderivatives and plug in numbers. It's important to note that you don't really have to get adventurous here and try to simplify anything, even something simple like 6/2. There's just no real reason to, so I'm not going to do it. And furthermore, I'm just going to plug the numbers in and then stop talking. Only reason I stopped there, well, I put a 0 there, I was just running out of room on the page. If I had done it differently, I guess I would have just written it all out, but I also didn't need to write minus this because I do know that if I put 0 in these 3 spots, I do get 0 for that second portion. So I hope that makes sense, and that's the end of problem A. Part B, write but do not evaluate an integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals 4. Very important to draw a picture. Since this is a solid of revolution, it's important to establish radii. I would suggest drawing them. You know that this is the center of the turn. Here's your outer radius and your inner radius. Okay, now these outer and inner radii will not just be the functions f and g. You have to think about it. The overriding principle is big minus little. So obviously 4, the line y equals 4, is bigger than or above f or g. So to establish a radius, you'll have 4 minus a function, so 4 minus f and 4 minus g. Part C, the region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is a square. Write but do not evaluate an integral expression gives the volume of the solid. So it might help to draw a cross-section. I'll pick one here deliberately. So that would be a cross-section perpendicular to the x-axis. I've chosen one that does fall partially below the x-axis just to point out that it really doesn't matter for the reasoning. The principle is big minus little. So whether the values of f are positive or negative just doesn't matter, because when you take g minus f, you're going to get a positive number, which is as it should be when you take a larger real number and subtract a smaller real number from it. The reason I square here is because the area of a square is given by the side length squared. The side length itself is clearly g minus f, which you can see in the picture. And that's the end of the problem. Just for funsies, I'm going to draw the solid of revolution from part B.